So hi everyone, welcome to this second video in this Verilog series. So first of all, in today's discussion, I wanted to emphasize mostly upon this arrays. Arrays in Verilog. In my experience and as well as when I have been seeing so many senior people, whenever we are taking this particular arrays in a wrong way or we are understanding this arrays in a wrong way, it's leading to so much of the confusion and which leads to so many failures. So let's try to understand this particular arrays in a righteous way so that whenever we are coding, we can just, if we can analyze how the simulator analyzes an array, it will be very easy for us to analyze the array and how to write that array and whatever the things or operations to be done on this arrays. So let's deep dive into this particular video. Generally, there will be two different or three different types of arrays with respect to Verilog. The first type of arrays are called as the packed arrays. The second type of array are called as unpacked arrays. And the third type of arrays are called as multidimensional array. In general, there may not be a particular types like this, but the spec defines the packed dimensions of an array, unpacked dimensions of an array, and with the particular thing which is having both the packed dimensional and an unpacked dimension are called as the multi-dimensional array. So that is the reason I have divided this into three different types. So today our emphasis will be completely on how can I define an array? After defining an array, how can I code it? Once I code it, how will the compiler understand it? So are there any other ways in defining that particular arrays? So the next series of the videos will be completely dependent on this particular array formats. So let's start with the packed array in this video. So the packed array. This type of array dimensions are represented in Verilog in a different in like reg. If we are considering a single bit, for suppose if we are considering a value a. So this says that this particular value in a Verilog is nothing but it's a 1-bit value. But if we are considering this one like reg 3 down to 0 a, this represents that this particular value can hold 4 bits. And the representation of this 4-bit is considered in terms of a packed array. So what does it mean by the packed? The name itself says that it can be completely packed as a single number. For suppose, if we want to represent 15, by using this packed array, we can represent it in this corresponding array. So this states that there are 4 possible locations which are packed in a single form. So the compiler understands whenever we are writing this particular statement like reg 3 down to 0, the compiler understands it in a different way. It will not understand it's a packed array. It will first understand like there are 4 different dimensions. I'm sorry. There are 4 different dimensions. So it will first consider a corresponding memory location and it will divide it into 4 locations, that is 3 down to 0, which is nothing but the 4 locations. Okay, so it will divide it into the 4 locations. So whatever the MSB value which we have given, that particular weight will be at this MSB. And whatever the LSB which we have given, that will be here. So as here it is 3, this is going to be 3, 2, 1 and 0. So this is how we are going to consider it's an 4-bit array. Okay. So generally whenever we are assuming an 4-bit array, first doubt which we are going to get is what is the least possible value and what is the highest value possible. So the least possible value will be all zeros together, and the highest possible value will be 1, 1, 1, 1, all ones. So generally, if we are considering a binary number of all zeros together, we are going to assume this as 0. And if we are considering all the binary numbers of 1 together, we are going to assume it as 15. And in the hexadecimal, it can be this F. So this is how the compiler will understand inside related to the packed array. Now let us just understand this in terms of a simple code. So as we are working on a simple test bench model only, I'm just writing in the TB. This is an EDA playground. Really, we need to thank this EDA playground. Because of this only so much we are able to understand so much of the VLSI in a handy way. So thank you, EDA. So as I'm running a simple TB module test underscore array. So end module. So first of all, here also let me assume an 4-bit array. So reg 3 down to 0 array. And as we have considered this one as a packed array, let me consider this as a P array, which is packed array. Okay. So let me take an initial, begin, end. So here P array is equals to, if at all we are giving it as 15. And now let me just use a $display statement like P array is equals to %0d, comma P array. So the first thing we will be very sure that whatever the value which we wanted will be directly 15, because whatever we have given we are directly printing it. But one thing which you can observe is here whenever I'm giving it in terms of 15, you are able to see it. Why? Because the packed array dimensions are making it possible for us. Now, just for our understanding, let me make this particular value as 10. Okay. Now, let me take a simple for loop. Integer I. So integer is a 32-bit variable. So let me take a for loop for I is equals to 0. I less than. See here, how many dimensions are there in the packed dimension? 4-bit. So which will be 3 down to 0. So here that's the reason I'm taking it as 4. And the Verilog doesn't support I++. That support is being given in the system Verilog. So that's the reason as we are discussing Verilog right now, I'm just focusing or writing it as I+1. Okay. So here I'm taking a $display statement A of %0d is equals to %d. So I want to print each and every bit, what is the value in that particular bit location. So here the first %d corresponds to the I variable and the second one corresponds to the A of I variable. Okay. So yes, so I think this will be helpful for us in understanding. So before going into the simulation, let us just analyze how are we going to write down the 10. 10 in terms of the binary bits is nothing but 4 tick B 1010. This will be the value of 10. So obviously the P array will be printed like directly P array equals to 10. But now when you come to this display statement, it will show like whatever that a of 0 value. So if we are assuming the reg 3 down to 0 as 10, reg 3 down to 0 a is equals to 10, what will the compiler do? The compiler will divide it. The compiler will divide it into 4 bits, where this value will be 3, this value will be 2, this value will be 1, this value will be 0. And here this value is 10. So the 10 can be represented in binary like 1010. So whatever this MSB1 will come here, the next value of the next to MSB will come here. The previous value to the LSB 1 will come here and 0 will come here. So which states that A of 0 is 0, A of 1 is 1, A of 2 is 2, and A of 3 is 3. Okay. So now let me run the code and let us see if we are expecting the same thing. So yes, I made a mistake. I'm sorry. In the 12th line. So A of percentage D. In the 12th line, I made a mistake. That is evident. So undeclared identifier A. Why I'm getting A as a wrong array? Because I have taken or declared the value of array to be P array, not A. So this is P array and this is P array. So now here you can see that the P array of 0 is 0, P array of 1 is 1, P array of 2 is 0, and P array of 3 is 1. So whatever we wanted, we were successful in retrieving the same thing. Okay. So this is about the packed array. In the next video, we will meet with the unpacked array, and in the next video, we will discuss the combination of packed and the unpacked array, which will be quite interesting in the Verilog. So yeah, please like, share, and subscribe to our channel Beacon Preceptor. And also, if you are having any updates regarding this, please let us know. I am ready to make that videos. So thank you. Thanks one and all. Thanks for your time and attention. We will meet in the next class with an unpacked array discussion.